Okay, so the questions are around about MATLAB R 2016 release, R 2016 release, along with some questions related to the data analytics, technical computing in data analytics. Hello, can you hear me?
Yes, you're going to ask questions about MATLAB, or do you want to just have an overview of MATLAB for 16?
Yes, you can give me some overview about more futuristic platform about R 2016 release.
Yeah, okay. Well, we've been investing heavily actually in the past few years, not just with 16A, but also 15B and 15A and beyond, 14B, in data analytics in a number of different areas. In terms of the algorithms, we continue to add new and improve existing algorithms for statistics, machine learning, computer vision, neural networks, and other data analytics applications. Maybe two examples specifically. In 16A, there is now a new convolutional neural network which enables deep learning. And so that's a brand new capability in neural network toolbox that came out in 16A. And then in 15A, we released the classification learner app, which is a point-and-click application in statistics and machine learning toolbox, which brings classification workflows to the MATLAB community. So that's a summary on the analytics perspective. In terms of performance, we continue to work on MATLAB performance and improve MATLAB performance so that it's a great environment for data analytics computation. We've got highly optimized libraries, just-in-time compilation, a new language execution engine that came out last year that dramatically sees a speed up of MATLAB performance. And MATLAB, of course, runs on multiple computing architectures, not just on computing desktops, but also GPU computation. MATLAB supports GPU computation. Other parallel computing structures can be done with parallel computing toolbox and additional capabilities in MATLAB, and other cloud and server-based technologies as well. And then let's see, so we talked about algorithms, we talked about speed, and we talked about cloud data. So that's kind of a summary of a large number of investments in, last would be big data. So we introduced MapReduce and Hadoop file structure support back in late 2014, 14B. So again, over the last year, 1, 2, 3 years, investing heavily in algorithms, performance, cloud, big data, and computing architectures.
Okay. So can you have some recent trends regarding the technical computing in data analytics solutions?
What was the question?
Technical computing and data analytics.
What about it?
A little more about
it. A little more. Well, okay. So those are. So I just gave you kind of a summary of the technologies. They're being used in a number of different applications. We are seeing them in a variety of both manufacturing, like automotive, aerospace, industrial automation, medical device, but also in financial services, retail, life sciences, healthcare management. So we see a number of different industries. Pretty much every industry is applying MATLAB and data analytics and technical computing to solve data analytics problems. These are things like predictive maintenance, fleet analytics, like in the automotive industry, operational logistics, supply chain analytics, healthcare management, obviously risk modeling and financial analysis, and a number of other different areas. We've seen companies both large and small, from major global manufacturers to small startup companies, all be able to apply these techniques and these technologies for data analytics applications.
So in financial industry, How do you see this technical computing trends will enhance the data analytics solution?
In financial services, there's clearly risk management and risk modeling are an important business opportunity and business requirement. And so we see lots of organizations all over the world using our data analytics capabilities for risk management and risk modeling. Specific examples could be things like looking to do loan approval analytics or credit scoring analytics and other types of risk applications. And what's interesting about finance is they have an enormous amount of data, as you might not be surprised to hear. And so one of the things they like about MATLAB is that MATLAB works across a number of computing architectures and technologies. So for example, they can prototype their analytic algorithm with a small set of data, but then when they're ready to deploy in real time, they're able to deploy the algorithm that they prototyped using MATLAB in a variety of different ways into a production IT environment, which is absolutely critical for them. So the flexibility of the computing architecture and being able to move the algorithm and the computation to wherever they need to move it is one of the technology value drivers that they see in working with these types of tools for these types of problems.
Okay, so in financial, it would be really beneficial of the high performance technical computing. Yes. So can you talk about the cloud trends that will dominate in 2016?
Sure. Well, probably one of the most visible applications of cloud is Internet of Things applications. And so I'm sure you've heard of the Internet of Things, but this is the world in which devices they do two things. They become smart devices themselves, and the way that they become smart devices is because they generate an enormous amount of data, and the data is then collected and analyzed. So what the cloud offers is a place in which to aggregate all of that data. So in many Internet of Things applications, there could be hundreds, thousands, tens of thousands of sensors out in the world collecting data in real time, and that data is then aggregated up into the cloud, and the analytics can be applied against the data at the point of the data aggregator in order to build a predictive model. So one interesting example of this is we have a customer that's building a smart building management system in which they're collecting a variety of different data sources and using analytics and optimization and control to automatically control the temperature set point in commercial buildings throughout the day, not just changing the set point in the morning and then sending it back in the evening. So this is a pretty sophisticated application with enormous amounts of data, and that's an example where they're using cloud or server-based technologies to store the data and do the analytics. There are a lot of different examples of that, but really what the cloud offers is flexibility around where the data needs to reside, and further, where the analytics need to reside. The way that those sensors and systems become smart is because the analytics that are created are deployed on those devices. In many cases, those are embedded devices. And we are seeing more customers incorporate analytics into their model-based design embedded systems workflow.
So how it will be like big data creating problems and how the technical computing solving that challenges?
Big data? Is that
Yes.
on big data? Yeah.
Big data.
Yeah. Well, big data is an interesting area because lots of people have lots of different definitions about big data. But what everybody agrees on is, for the first time, really ever, analysts have access to an enormous amount of data, more than they ever could have access to before. These data are generated again from these smart sensors and smart systems that I talked about. They're generated from other traditional business or transactional systems, and you're seeing terabytes and petabytes of data stores being collected. Why this matters for data analytics is this, along with the new computing power I talked about earlier and the computing flexibility, this now allows us to apply long-standing methods in machine learning and statistics against these massive data stores. This was not something we could do, let's say 20 or even 10 years ago, but today we can. And so what this has done, it has brought high-end data analytics to the masses. It's enabled an enormous number of data scientists and data analysts to apply big data analytics algorithms, machine learning, neural networks, classification algorithms, decision trees, support vector machines. All of these techniques can be applied against these massive data stores. I'll give you an example of where this matters. Fraud detection in the financial services industry. It's obviously very important to detect fraud. Fraud is a low occurring event. And so you almost need big data in order to have sufficient data to have sufficient number of occurrences of fraudulent transactions in order to be able to build a powerful predictive model of a transaction that's likely to be fraud. So that's a real pragmatic example of how big data can solve a real problem today that was much more challenging to solve 20 years ago or 10 years ago.
So can you please explain the growth of this high performance data analytics solution?
The growth?
Yeah, growth of high performance data analytics.
Well, it's hard to put a number on it. I mean, we're seeing it in every industry. We are certainly seeing our products being used across automotive, aerospace, industrial automation, financial services, retail, medical device, healthcare management, life sciences. It's really difficult to give a specific number other than telling you that it's growing all the time. Now, one thing you may be familiar with, and it is another indicator of this growth, is a lot of people talk about the shortage of data scientists. So if you haven't heard about that story, a data scientist is an individual that has 3 skills. Number one is they're an expert in their domain. You know, they're in finance, they could be an expert in financial, in the financial business. The second skill is they understand computation and computing technology, and they know how to apply the principles of computation, coding, and IT to solve problems. The third piece, though, is they also have statistical and machine learning skills and experience. You probably wouldn't be surprised to hear it's rare or difficult to find an individual that has all 3 of those skills or experience. And so an indication of the growth of high-end data analytics is there are a lot of articles being written about a worldwide shortage of data scientists. There are so many applications in so many industries. There's a belief that there's a real shortage of people who can apply those 3 types of skills to solve those problems. Now, our perspective is we enable the domain experts who already have the domain expertise and understand computation. If they're MATLAB users, we bring the data analytics and the data science algorithms to them immediately, because in the case of engineering-driven analytics, MATLAB and Simulink are designed around the engineering data analytics workflow. And so we basically allow today's engineers to be today's data scientists through the use of MATLAB. So that's a real solution to a real problem that people perceive to be out there.
So what is the business test analysis by simulation?
Well, where we're seeing organizations and users of our tools combine analytics and simulation is simulations are becoming more sophisticated. You've got system level simulations for the automotive industry, the aerospace industry. These are very, very complicated simulations where they're simulating entire systems or subsystems. That means when they run those simulations, they're generating again an enormous amount of data about the simulation. The beauty of analytics is now you can apply sophisticated analytic methods to the output data from your simulation runs in order to understand if the simulation's doing what you want it to be doing, to help you verify and validate your simulation, and ultimately improve the efficacy of your simulation. So you use analytics to analyze the data that's produced from your simulation, ultimately to improve your simulation and the models inherent in that simulation.
How MATLAB and Simulink products helps to drive this business trend analysis?
I didn't catch that.
Yeah, could you please repeat that question, Vaishali?
How MATLAB and MATLAB Simulink software helps to drive this trend?
To drive these trends?
Yeah.
Well, Simulink. So I talked about analytics or analysis and simulation. You can think of MATLAB and Simulink as the platforms. MATLAB as the platform for analysis, and Simulink as the platform for simulation. And so these large system models are being designed in Simulink, and the output from those Simulink-based models is being analyzed with MATLAB. But I'll take it a step further. I mentioned earlier about the Internet of Things and smart systems and smart devices. In many cases, those devices are designed with model-based design, which is an embedded systems process and workflow based in Simulink. But what you can do is you can use MATLAB to develop your predictive analytic, and that predictive analytic that you've built in MATLAB plugs directly into your model-based design workflow so that you can deploy a smart system, an analytically capable embedded system. So the way that MATLAB and Simulink work together is you really bring analytics into embedded systems design in a single integrated set of platforms built around MATLAB and Simulink.
So what is the theme at MATLAB Expo to offer this data analytics solution?
The keynote?
The theme.
The theme. The theme is engineering-driven analytics. And what we mean by that is, while general analytics is certainly highly pervasive, you're asking me lots of questions about analytics, everybody's interested in analytics. We see the fact that engineering and engineering data are really becoming critical in a lot of these applications. Let me explain what I mean by that. You can think of traditional business data as coming from traditional transactional systems. A financial services system, a retail system which records, the products that you might buy at a store or an online retailer. That's one source of data. But another critical source of data is engineering data. This is data generated by machines, by smart systems, smart vehicles, drones, unmanned aircraft, all types of Internet of Things applications where the machinery is generating data in an always-on fashion. So massive amounts of engineering data, and that data is being combined with the traditional business data, and applying analytics to that combination of engineering data and business data really produces a better outcome, a better predictive model, a better analytic for wherever you want to ultimately deploy it. And so that's the theme, is engineering-driven analytics.
How are you approaching your customers for data analytics solutions?
Well, we approach customers in a number of different ways. I'd say there's sort of 4 layers. The first two layers are about our software. The second 2 layers would be about our services. The first software layer are the tools, MATLAB, Simulink, the toolboxes, and other products from Mathworks that enable engineering-driven analytics. But the second layer is, on top of those tools, we provide a number of apps. These are applications that implement in a point-and-click visual interface manner common data analytics workflows. In addition to apps, there are hundreds of examples, smaller examples of analytic applications that people can download from our website to get started. So again, the first layer are the core products. The second layer would be apps and examples. Now, moving to the third layer, this is where we work with teams with local technical resources. In India, we have a team of people across the country who work with customers every day to help our customers adopt those products and those applications and those examples to their particular business or technical problem. And then in addition, there are a number of training services, both online and in-person training, either general purpose or customized training for customers. And then that's the third layer, would be the support from the technical people, including training. And then the fourth layer would be consulting services, where we have a consulting organization, a worldwide consulting organization, that will work with customers to help customers build complete solutions and complete applications. So it's a 4-layer approach to enabling customer success.
Okay, so my next question is, would you like to put any issues or challenges with respect to this product?
Issues and challenges that we see from our customers?
Yeah.
Oh, there's lots of them. Probably the most famous challenge, and this is not unique to our customers, this is true for everybody out there doing analytics, is preparing the data. You know, people say if you're doing an analytics application, 80% of the work is actually in the preparation and management of the data. And you remember I talked about all of these different sources of data. Well, they're coming in different formats. They're coming in different file structures. And so it's a real challenge for organizations to figure out how to combine all of these different data sources together and prepare the data for analysis. That's a general challenge. Now, having said that, one of the nice things about MATLAB is MATLAB's been designed from the beginning to process engineering and other sources of data. And it's fairly straightforward to use MATLAB to help organizations deal with this data management and data preparation problem. So that's probably one very visible challenge. Another challenge has to do with the fact of big data and these smart systems, and companies trying to figure out where to move the computation and where to move the analysis. You know, the advantage of bringing all of your data together and doing the analysis against all of your data is, if it's a situation where you really do need a lot of data, you'll get a better result. But, as you might imagine, that has trade-offs, right? It's more difficult to move all of that data. It takes longer. You need larger data stores, more compute power. So there's a trade-off from a computing infrastructure perspective with where you want to move the data, how you want to aggregate the data, and where you want to apply the analytic. If you want to, take a subset of that data and move it to, a different compute lab or some kind of a computing farm, you can do that. The trade-off there is you might get your analytics done more quickly, but you're not running it against the entire data set. Another advantage of working in MATLAB is because MATLAB runs, basically it's always the same, it's MATLAB everywhere it runs, but it runs on all of these different computing architectures. The customers have to make the trade-off from a business and a technical perspective on where they want to put the data and where they want to do the computing. But basically, whatever they decide, they'll be able to implement with MATLAB.
Okay, my last question is related to, can you compare MATLAB with other languages in data analytics?
Are there other
Languages in data analytics. Compare it.
Oh, well, there's all kinds of languages out there, so it's hard to compare. What I would say is MATLAB is a comprehensive language. It's the language, well, it's the language of technical computing. It's the language of analytics because, as I mentioned, the type of data that people are using spans not only traditional business data but also engineering data. And MATLAB inherently, from day one, is designed to read in and process engineering data. The other important aspect of MATLAB as a language is the toolboxes bring to the users all of the common domains in engineering and science, from signal processing to image processing to statistics to control to computer vision to machine learning, neural networks. You've got pre-built algorithms, proven, trusted algorithms, pre-built, shipping with the toolboxes that just run natively on top of MATLAB. And so the language is incredibly powerful, it's incredibly flexible, it spans the entire domain of engineering and science, and it's incredibly fast and optimized and can be run across different computing architectures.
Okay, so just one question. Can you explain about the future outlook of this data analytics and what will be coming, the next year, new applications coming?
Well, we don't. We make a habit not to pre-announce specific features, but generally, we are continuing to invest heavily in all of the areas. We continue to add algorithms to the toolboxes and to core MATLAB. We continue to work on performance. We continue to work on big data and compute flexibility. We continue to invest in things like GPU computation. We continue to invest in enhancing existing and exploring new domains. And so every release, one of the nice things I think about our strategy of these twice yearly releases is it's a little easier for customers to absorb. Rather than waiting a period of time and seeing this massive release, every year, twice yearly, there's a new set of features, a new set of capabilities that customers can learn about and figure out if it's right for them. And it's through events like MATLAB Expo is a great way for customers to stay current and learn about all of the new features, all of the new capabilities that have come in the last release or the last two releases. And so certainly you're happy to see great turnout in Bangalore last week, Pune today, and we certainly will see the same thing in Hyderabad on Thursday. And again, the Expo is just a great way for customers to get in one day a pretty good overview of all of the new capabilities.
Okay, thanks. Is there anything else you would like to put from your end, Rich?
Anything else that you would want to add?
No, I think we covered it. It was important to get the point out about MATLAB Expo. I think I would encourage people to, if they weren't able to make MATLAB Expo this year, to plan on attending next year, where it will be even bigger and better. And we see engineering-driven analytics as really, really an innovation that's